does our brain make sense of everything that goes on in the outside world? And what are some of the general rules that our senses have to follow? Today we're going to take a look at the biological basis in psychology when it comes to sensation, the process of taking information in from our senses and turning it into something that our brain can understand. And that really is the job of sensation. It is taking this sensory stimuli or these stimuli energies from things like sound waves and light waves and turning it into something that our brain can make sense of through the neurotransmission process. And this process of turning that stimulus energy into something that our brain can understand is referred to as transduction. We can transduce light waves into something that our brain can see, or we can transduce sound waves into something that our brain can hear. There's a lot of stimulus energy that is taking place in the world around us. And actually, we're not able to comprehend all of it. A stimulus has to enter into our conscious awareness for our brains to be able to make sense of it. And that's where thresholds come into play. We have absolute and difference thresholds that allow us to perceive information coming in from the outside world. An absolute threshold is the minimal amount of stimulation that we need in order to detect a stimulus about 50% of the time. So if we use hearing as an example, that would be a sound that is just faint enough that you think you hear it about 50% of the time, and at that same level, the other 50% of the time, you're not sure if you're actually hearing anything. It's the smallest amount of sound that we need in order to perceive that there is in fact a sound there. And this is true for all of our senses, not just hearing. But what if that sound gets a little bit louder, and a little bit louder again, and it continues to get louder? Anytime you can detect a change in that stimuli, it's referred to as a difference threshold, or the just noticeable difference. And that is the smallest change that needs to take place for you to notice that something has in fact changed, that there is a difference between the two stimuli. And the just noticeable difference follows a law called Weber's law that says that when that change takes place, it needs to be a constant percentage and not a constant amount. Let's take weight for example. If you were to pick up a 10-pound weight and then an 11-pound weight, chances are you'd be able to tell the difference of which one is heavier and which one is lighter. That's because it's a 10% increase between 10 and 11 pounds. Now, if you were picking up 100 pounds and 101 pounds, you might not be able to tell the difference between the two weights, which one is heavier and which one is lighter. Because now, even though it's still a 1 pound increase, we are talking about a 1% increase. And because that change is percentily smaller, you might not be able to notice the difference. So whatever that percentage is, it could be 5%, it could be 10%. But whatever it is, it will need to continue to be that as the percentage increase goes up for you to still be able to detect a change in the stimuli. That's what Weber's law tells us. And sometimes you will have a stimuli that is present in your environment, but you do not notice it, or it's not as strongly noticeable as time goes on, and that is due to sensory adaptation. If you have the same stimuli being presented over and over again, let's say, for example, you have a watch or a bracelet on, and you get that information being sent through your skin up to your brain about the sense of touch. After a while, because you don't really need that information, you become desensitized to it. You have sensory adaptation. Now, if you move that watch or bracelet to a different area of your wrist, you might become more aware of it all of a sudden, because now we're activating a new area of our skin. As time goes on, however, due to sensory adaptation, eventually you'll get used to it. Same thing happens with other senses like smells, where you might not notice the scent of your own home, but you might notice other friend or family members' houses have a distinct scent to them. We've become used to our own, and so we have adapted to that sensory information where we might not have done so in other locations. And of course, all of our senses interact with each other. Taste and smell, for example, work together to help us create the perception of flavor. And even vision and taste can play a role with each other. If something doesn't look appetizing to us, it can actually affect the way that our brain perceives those flavors. And even though we do technically have different areas of the brain for each of our five senses as we process that information, sometimes those pathways can converge. And it is a unique phenomenon known as synesthesia. Synesthesia is when people have a combination of different sensory experiences. So, for example, when they see different letters, they might also see them in different colors. Or when they hear specific notes of music, they might see changes to colors in their visual fields. Or when they taste different foods. It's the combining of different senses that change their perception of their world around them. Different people have synesthesia in different types of ways, but it is a really unique and kind of cool phenomenon. So that is sensation as a whole. Next up, we'll get into each of our specific five senses and how that information is transduced into something that our brain can understand. So thank you so much for watching, and as always, remember, be kind to your mind.